All right, my friends, welcome to section 3.5, part 2. Still derivatives of trig functions. In part 1, whoops, that's not an S. In part 1, we talked about what the derivative of sine and cosine are. I hope that you have those derivatives memorized from here on out, to be honest with you, but particularly as we go through this lesson. It will come in very handy. We're going to use that as a building block as we move forward. So why are we still talking about derivatives of trig functions if we already know the derivative of sine and cosine? Well, we still have tangent, cotangent, secant, and cosecant left. So let's just go ahead and get started on that. So let's say we're trying to figure out what the derivative of tangent is. So a lot of people are like, oh no, here comes another definition of derivative proof, but we actually won't need it. So really what you could do to discover, we're actually going to go ahead and just summarize what it is at the end here. To discover what the derivative of tangent is, you could actually not do the derivative at all yet and just replace tangent with sine of x over cosine of x. And why would I do that? Well, my friends, we know the quotient rule for derivatives, and here we have one function of x divided by another one. So we don't have to go back to definition of derivative because we have another rule that we could use instead. So the derivative of sine of x divided by cosine of x, you're going to see me use low d high minus high d low all over the bottom squared we go, which I've heard at least one person in your class uses, instead of the Swedish accent, they use a southern drawl for that. Anyway, whatever it takes for you, let's do this derivative using the quotient rule. So low would be cosine of x. D high, derivative of sine is cosine, minus high. D low, derivative of cosine is negative sine of x. All over bottom squared we go. There we go. All right. Now let's simplify what we have. So we've got cosine times cosine. Well, that's cosine squared x. And we have minus sine of x times negative sine of x. That would be plus sine squared x. And it's all over cosine squared x. All right, my friends, watch your notation. Equal signs are nice and lined up. All right, cosine squared plus sine squared. Come on, now what's that Pythagorean for? It is always equal to 1. And 1 divided by cosine squared, let's see, well, 1 over cosine is secant, so 1 over cosine squared would be secant squared x. All right, so from here on out, you are expected to know from memory that the derivative with respect to x of tangent of x is secant squared x. I'm going to put a memorization cloud around that, and then I'm also going to put a little box to show that we have proved this is true. There we go. All right, so take a moment and do your best to cram that into your short-term memory, and then we're going to move on to ddx of, let's do cotangent of x next. Okay, this is a really good time for you to pause the video and see if you can do this one on your own. It's very similar to what we just did. Assuming that you have paused the video and you're just checking your answer now, this is how I would go about this. So this is the same as ddx. You need to write ddx here because we haven't done the derivative yet, so make sure you have that. And then cotangent is the same as cosine of x over sine of x. All right, my friends, now using the quotient rule, low, d high, derivative of cosine is negative sine, minus high, d low, derivative of sine is cosine. All over the bottom squared we go. Simplify. I'm also going to factor this negative out that's on the top. So I'd have a negative 1 basically times sine squared x plus cosine squared x. It's all over sine squared x. So sine squared x plus cosine squared x is equal to 1. So you'd be left with negative 1 over sine squared x. Since 1 over sine is cosecant, this is equivalent to negative cosecant squared x. All right, so another thing for you to memorize, d dx of cotangent of x is negative cosecant squared x. Okay, now I know these are the things at the end of your accelerator pre-cal year, but these are your ABCs when it comes to Calc BC. And so folks who do not know these identities going into next year will struggle. Okay, all right, my friends, we have 2 trig functions left. Let's go ahead and look at d dx of secant of x. Similarly to what we've done before, d dx of secant would be the same as d dx of 1 over cosine of x. We're going to go ahead and use quotient rule. Low, d high, minus high. Derivative of cosine is negative sine, d low. All over the bottom squared we go. All right, simplify this. You're going to have sine of x over cosine squared x. And the truth is that is equal to the derivative, but we've tried to avoid having all the derivatives of trig functions be in terms of sine and cosine, so it'd be even harder to remember everything. So what we would do with this is we'd rewrite it as, so the denominator would be like cosine x times cosine x. That would give you cosine squared x. And then we'd have 1 times sine of x to give you that sine of x back. And then 1 over cosine is, who's that? Secant of x. And sine over cosine is tangent of x. And so from here on out, you're expected to know d dx of secant of x is secant of x times tangent of x. Memorization cloud for you. And a little box to show we proved it. All right, last one, my friends, d dx of cosecant of x. And go ahead and discover it through the proof. This would be the same as d dx of 1 over sine of x. Quotient rule, low, d high, minus high, d low, derivative of sine, negative cosine, all over the bottom squared we go. Simplify it, you'd have cosine of x. Do I have a mistake? No, the derivative of sine is positive cosine. All right, you'd have negative cosine of x over sine squared x. All right, let's see. Breaking this up, again, we're trying to avoid your derivative rules all being a bunch of sine and cosine stuff. It would really make it harder to remember. So let's see, let's write the denominator as sine of x times sine of x, and then the numerator as maybe like negative 1 times cosine of x. All right, negative 1 over sine of x, that's negative cosecant of x, and cosine over sine, that's cotangent of x. All right, so d dx of cosecant of x is the opposite of cosecant of x times cotangent of x. Something to memorize. And we also proved it. There we go. All right, my friends, two examples, and then we'll wrap it up. Okay. All right, example 3. Actually, is it example 3? I think it's example 4, actually. There we go. Okay. Let's see. Ooh, actually, last example. Yeah, well, let's just do one. You don't need to work so hard. Okay, let's give you, the directions are just to differentiate. And let's give you y equals 5 times theta over tangent of theta. All right, my friends, go ahead and see what you can do with this. Okay, one issue some folks have with a problem like this is we've done everything in terms of x and this is in terms of theta. And so some folks who are doing their best to stay on top of notation aren't sure what to do here. And so just to make sure, is basically if you don't have x's, you have something else. You just take derivative with respect to that, that variable. So basically, you're going to take the derivative with respect to theta of both sides. And I'm going to show this little dirtbag math step that you super don't have to show. But it's just me saying, hey, we're going to take the derivative with respect to theta of both sides. Which would explain, I hope, why we call our answer what we do. So d theta of y would be called dy d theta. Again, remember that the long names for these, this is derivative with respect to theta of y, and this means the derivative of y with respect to theta. And if you really listen to what I just said, those two things should be equivalent. Okay, now for the derivative on the right side, we're just going to use quotient rule. So you could do low, d high, minus high, d low, derivative's tangent is secant squared theta. All over the bottom squared we go. Okay, simplifying this, we could just write it as 5 times tangent theta minus 5 theta times secant squared theta all over tangent squared theta. That is a perfectly fine answer. Now, let's say this was multiple choice though, and you do this problem, you're pretty confident you did it right. You do not see anything that looks like this, and so right before you circle E, none of these, you'd want to try to simplify it maybe just a little bit. So think about tangent is sine over cosine, secant is 1 over cosine, and then 1 over cosine here. So what you could do, let's see, what could we do here? We could just write everything in terms of sine and cosine. So I'm going to box this because it's a perfectly good answer. But let's talk about other ways it could look. So you could have 5 times tangent theta. That would be like 5 times sine of theta over cosine of theta minus 5 theta. Secant theta is 1 over cosine squared theta. And then tangent theta is sine squared theta over cosine squared theta. So basically, another way this could look is like this, but then somebody flipped and multiplied with this compound fraction. So you could have 5 sine theta over cosine theta minus 5 theta cosine squared theta times cosine squared theta over sine squared theta. There we go. And then if we distribute this in, then one of these cosines and sines would cancel with these, so you'd be left with 5 times cosine theta over sine theta minus, and then if you distribute it in here, the cosine squareds would cancel, so you'd be left with 5 theta essentially times 1 over sine squared theta. So another way that your answer could look, which would be totally equivalent to this, would be 5 times cotangent theta minus 5 theta, and then 1 over sine is cosecant, so cosecant squared theta. Okay, so we'll just box them both. They're both considered perfectly valid answers. One is not more correct than the other, but I'm just showing both because the idea of things being multiple choice, and you don't want to do all the calculus correctly and then get the problem wrong because you didn't notice some basic algebra manipulation that they had. All right, my friends, that is it. That is your last notes for your year of accelerator pre-calculus. I hope you feel like you've learned some things, and I hope that whichever math class you are taking next, from whichever professor, I hope you feel well prepared, and I hope you feel like your hard work is paid off. And speaking of your hard work, thank you so much for it, and thank you so much for not throwing in the towel when we had to go online. Thank you so much for continuing to nurture your ability and to take your, those of you who have taken your education so seriously. This stuff is going to pay off for you your whole life, and I'm just real proud of you for investing in yourselves the way you have. So anyway, that's it. I'm going to stop talking. Take care, everybody.